Hi, welcome to Physical Science, Chemistry Unit 3 on chemical bonds. This will be 3.1b, talking about the types of bonds and introducing the polyatomics and transition elements. So first with the types of bonds. For bonding purposes, remember that everything to the right-hand side of the stair-step line is considered a non-metal, and everything to the left-hand side of that stair-step line on your periodic table is considered a metal. There are two primary types of bonds: ionic, where the electrons are lost and gained between atoms. These occur between metals and nonmetals, and they will use the oxidation numbers. Then you have covalent bonds, where the electrons are shared between the atoms, occur between two nonmetals, and you will be given the number of each element to combine. We're actually going to start with covalent. Covalent bonds, remember, bond two nonmetals together in sharing the electrons. Okay. Then you have ionic, and there are four types of ionic bonds. Perfect ionic, where the oxidations cancel out, there are no subscripts. Crisscross ionic, which is the majority of them, where the oxidations will crisscross to become the subscripts. Polyatomics, which are preformed ionic bonds that will bond again with other elements and compounds. And finally, transition elements. Transition elements are that block 3 through 12. You're given its oxidation number as a Roman numeral, and they will bond with nonmetals because they're on the left-hand side. They're considered metal. So, examples of covalent. 2 carbon and 3 oxygen will make C2O3. Remember, for covalent bonds, they are their own subscript. So the subscript goes behind the letter to identify how many you have. Just like in math, you would use a superscript or an exponent to mean x squared would mean x and x. C2 means 2 carbon. 1 nitrogen, 2 oxygen makes NO2. 3 phosphorus and 1 chlorine would make P3Cl. Notice that if we only have one of something, we don't always write the number 1. Just stop doing that. It's like in math again. If you have one of it, you just write the letter. All right, these are examples of perfect ionic compounds: sodium and chlorine. Sodium is Na, which is a 1 positive. Chlorine is Cl, which is a 1 negative. They combine together to make NaCl. Notice that the positive did come first. Magnesium and oxygen has two formulas that are correct. The molecular formula is Mg2O2. The empirical formula is MgO. Neither one of those is wrong. Most of the time, however, I will be asking you for the empirical formula. Think of it as simply reducing the compound. Just like in math, you wouldn't leave a fraction as 2/4. You would say it's 1/2. Okay, these are crisscross ionic bonds. Hydrogen and oxygen, remember, hydrogen is a 1 positive, oxygen is a 2 negative. The 2 comes down, the 1 comes down to make H2O because 2 hydrogen combine with 1 oxygen. If we combine calcium and chlorine, calcium is Ca, 2 positive, chlorine is Cl, 1 negative. They crisscross again, 1 comes down, 2 comes down, making CaCl2. 1 calcium combines with 2 chlorine. Okay, the next few slides you're going to want to have that handout that I'm giving you that's fill in the blank on polyatomics. Polyatomics are already ionic preformed compounds, and they have unique names given to them that you will use, and their own unique oxidations or charges. and they can and will ionically bond with other compounds and elements. Okay? So, on your fill in the blank sheet, the top box is for polyatomics that have an oxidation of 1 negative. They are acetate, bicarbonate, chlorate, cyanide, hydroxide, nitrate, nitrite. Okay, so those are the polyatomics that will have an oxidation of 1 negative. Their formulas go with them, so be very careful to fill in the blanks. Acetate's formula is C2H3O2. Bicarbonate is HCO3. Chlorate is ClO3. Cyanide is Cn. Hydroxide is OH. Nitrate is NO3, and nitrite is NO2. Second box down on your sheet are polyatomics with an oxidation of 2 negative. Those will be carbonate, chromate, peroxide, sulfate, sulfite, and silicate. The formula for carbonate is CO3, chromate is CrO4, peroxide is O2, sulfate is SO4, sulfite is SO3, and silicate is SiO3. Finally, you have some polyatomics that are not all the same. So I'm going to give you the oxidation, their name, and their formula. So with an oxidation of 3 negative, you will have phosphate. A 1 positive oxidation is ammonium and ammonia. Spelling's very important. Also with a 1 positive is hydronium. And with an oxidation of 0 is methane. Since it has an oxidation of 0, it won't bond to anything. However, you do need to know that it does exist. Phosphate's formula is PO4. Ammonium is NH4, while ammonia is NH3. Hydronium is H3O, and methane is CH4. That should completely fill in that polyatomic sheet. Now let's look at some examples. If we wanted to combine aluminum, that has an oxidation of 3 positive, and sulfate, that has an oxidation of 2 negative, they would crisscross. But notice I have a parenthesis now. The polyatomic has to stay joined together. It is its own thing. So this would be read Al2 SO4 3. Again, if I want to combine potassium and nitrate, K1 positive and NO3 1 negative, I would make KNO3. I don't need the parentheses because there's not an extra subscript on the outside. Ammonium and chlorine. Ammonium is NH4. Chlorine is Cl with a 1 negative. They would combine together to make NH4Cl. And ammonium with nitrate, because a polyatomic will bond to another polyatomic, would make NH4NO3. We're still using the crisscross method or the perfect method because the oxidations match. But notice the positive always comes first, no matter if it's a regular element or a polyatomic. Finally, let's talk about those transition elements. This is groups 3 through 12 on your periodic table. The transition elements get their name, they're called transitions, because they have variable oxidation numbers. Their oxidation numbers are always positive. That's why you wrote positive oxidation on it. You are told or given the transition element's oxidation with a Roman numeral. If you don't know the Roman numerals, I will be putting them on the board. These transition elements will bond ionically with other elements and compounds. So you're going to treat it just like you would calcium or magnesium, simply because we're going to tell you what its oxidation is. So examples are combine copper 1 and oxygen. Well, copper 1 is Cu1 positive and oxygen is 2 negative. They crisscross to make Cu2O. Iron 3 and chlorine, again, iron is Fe, 3 positive. Chlorine is Cl1 negative. They crisscross to make FeCl3. We're going to do lots of problems in class. Thanks for watching.